I want to link continuity to derivatives. So let's remind ourselves of what derivative is. Derivative is a limit. It's the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, I want to make a link between these two things, and I'm actually going to use these criteria to do it. When we say the limit exists, what do we mean? Well, from some point of view, that could be that the limit as h approaches 0 of f of x exists. Right? Because what is f of x plus h? As we've seen before, f of x plus h is just wherever you are along the function other than at the point x. And as h approaches 0, the 2 points approach one another. So here, what's approaching is just the function value. So if the limit exists, well then this limit is going to have to exist. 2, we know that f of x would have to exist. Because, well, for the function to exist, you're going to have some f of x value. Plug in f of x, you're going to have to be somewhere. And then 3, and now here's the key, is these two things have to be equal. So the limit as h approaches 0 of f of x plus h has to equal f of x. The limit exists, the function exists, and the two are equal. So here's maybe a more rigorous way to say what is in the square brackets on the left side of the board. And let me take one moment here to rewrite this statement, number 3, in a slightly different way. If the two things are equal, when you subtract them, they would be 0. Right? Any two things that are equal, subtract them, you get 0. And now, as I write this statement, you can start to see visually a link between the derivative and the expression of continuity.